Alright, in this video we're going to use what we talked about in the previous video with multiplying matrices to find the inverse of a matrix. Well, what do I mean by that? Well, first, why don't you guys go ahead and pause the video and choose one of these to do. Since you're not in my classroom, choose one of these to do. Multiply these two matrices together using those skills, like I said, that we just learned about, and find out what ends up happening. Well, regardless of which one you chose, when you multiply 1, 0, 0, 1 matrix by the other matrix, the answer ends up being the same as the original. Which brings us to talking about this identity matrix. Well, the matrix 1, 0, 0, 1 is called the identity matrix for a 2 by 2 matrix. Now, just like 5 times 1 results in 5 as your answer, 1 times 7 results in 7 as your answer, multiplying a 2 by 2 matrix by this identity matrix results in the same matrix, and that's what you guys just found. Now, we can define the inverse as, so up above there we say see a and then a to the negative 1 exponent. Remember from what we've seen with functions, that negative 1 exponent means that we're referencing the inverse. So when we multiply a times its inverse, or an inverse of a times a, the result is going to be the identity matrix, 1, 0, 0, 1. Now we're going to look at how to calculate the inverse for a 2 by 2 matrix. Now here's some rules that we need to follow. First off, it can only be done with square matrices. So that means like a 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, and so on. But we're going to do these by hand in this lesson. So we're only going to do it for a 2 by 2 matrix, because if we were to try to do this with a larger matrix, it's going to be a lot more complicated. So for example, if I had matrix A being 4, 8, 1, 3, its inverse would be this: 0.75, negative 2, negative 0.25, and 1. So if we were to multiply A times that inverse, we end up getting the inverse, or get the identity matrix as the answer. And this just basically just proves that. It's not showing us how to find the identity matrix, but it's just showing us how those work together. So let's look at the process of actually finding the inverse of a 2 by 2 matrix. So the first step, we're going to find what's called the determinant. Now, the determinant is found by multiplying across a times d and b minus c and subtracting those products. So it's the difference of the cross products is how you can look at it. So again, a times d, b times c. And that is what we call the determinant. And we're going to hold on to that number for a minute. But then the next thing we're going to do, we're going to swap the elements in the leading diagonal. What does that mean? We're going to take that a and d and swap them. Now, we can't just leave the b and c alone. They're feeling left out. So we're going to make the b and c the opposites of what they were originally. And the last step is we're going to multiply that matrix that we have by the reciprocal of the determinant. So how does that all work? Let's calculate what that determinant would have been for that matrix that we saw earlier, 4, 8, 1, 3. So the first step, we're going to find the determinant. So we're going to find the difference of the cross products. So we would take 4 times 3 and 1 times 8 and multiply those together, or subtract those from each other, and we would get 4 as our answer, because 12 minus 8 would be 4. So that's our determinant. Again, we're going to hold on to that for right now. The next step, we're going to swap those elements. So the 4 and the 3, we're going to switch those two. And then this third step is we're going to take the opposite of those other two elements. The negative, or the 8 and the 1 would become negative 8 and negative 1. And then the last step, we're going to use that determinant, and we're going to take the reciprocal of it and treat it now as a scalar that we learned about in the very first lesson in this unit. So now I'm going to multiply every set, or every element in that matrix by 1/4. And the result is 0.75, negative 2, negative 0.25, and 1. And again, we could check to make sure that this all works together. So if we multiplied these two matrices together, sure enough, we would get 1, 0, 0, 1, the identity matrix, as our answer. Let's try another one. Now, to make things easier, we don't always have to go through all 4 of those steps separately like we did in the previous example. So I'm going to show you how we can combine steps 2 through 4. Now the first step, we're going to start out again by finding the determinant. The determinant is going to be 2 times 5 And 6 times 1, so 2 times 5 is 10. 6 times 1 is 6. 10 minus 6 gives us 4. So now we're going to take and combine 2 through 4. So we're going to take the reciprocal of that determinant, which would be 1/4. We swap that diagonal, so the 2 and the 5, we swap those to get 5 and 2. And then we negate, or take the opposites of those other two elements. The 6 and 1 become -6, -1. And now we just go ahead and multiply those elements by 1/4 to get 1.25, -1.5, -0.25, and 0.5. So doing it that way is a lot easier than doing all those steps separately. All right, I want you guys to try this one. So go ahead, pause the video, and hit play when you're ready to check to see if you have the correct inverse for matrix C. All right, let's see how you did. First off, the determinant you should have gotten is 10. Then we would take the reciprocal of that. The reciprocal of 10 would be 1/10. And then we swap the -5 and 2 to get 2 -5. Now remember, here we have some negative numbers. So remember, we're taking the opposites of those other two elements. So then 20 becomes a -20, and the -1 becomes a +1. And now when you multiply all those by 1/10, you end up getting 0.2, -2, 0.1, and -0.5. How would you do? Did you do all right? Well, let's try it with one more. So why don't you guys go ahead and find the inverse for this matrix. So again, pause the video and hit play when you're ready to check to see if you did it correctly. All right, let's see how you did. So the determinant for this one would be -2, because 2 times -1 would be -2, but 2 times 0 would be 0, so we just get -2 there. So we take the reciprocal of that, which would be 1 over -2, or you could have said -1/2. Swap the 2 and the -1 to get -1/2. Take the opposite of 2 and 0. Well, there's no 0 is neither positive nor negative, so we just leave that as just 0. Now when I multiply everything by -1/2, I get 0.5, 1, 0, and -1. And that's it. So when you look at it that way, it's not as difficult here to find the inverse of a matrix. So good luck now as you work on your homework assignment.